In 1950, the People's Liberation Army Air Force had fewer than 100 flyable aircraft. Most of them were Soviet cast-offs. The pilots had been trained in months, not years. The mechanics were reading manuals they barely understood. 76 years later, that same Air Force fields over 1,500 frontline combat aircraft, 2 simultaneous fifth-generation fighter production lines, the world's most advanced carrier-based stealth fighter, and at least 2 confirmed prototypes of whatever comes after that. No other country outside the United States has made this kind of leap, not Russia. Not anyone. This is not a story about threats or intentions. This is a story about hardware and the sheer scale of what China has built. Every aircraft type, every role, every generation. From the oldest trainer still flying circuits to the tailless stealth prototypes that have already rewritten the assumptions of Western intelligence analysts. This is the complete inventory. Chapter 1. Learning to fly someone else's jet. Before China could build anything, it had to learn to fly something. The aircraft that started it all was not even Chinese. The Nanchang CJ-6 is a twin-seat, single-engine piston trainer derived from the Soviet Yak-1-8, and it entered production in 1962. Roughly 400 of them are still in service today. That is not a typo. A propeller aircraft designed in the early Cold War is still the first machine that most PLAAF pilots ever put their hands on. It is slow, forgiving, and cheap to operate. It does exactly what a basic trainer is supposed to do, and it has been doing it for over 60 years. From there, the pipeline moves to jet power. The Hongdu JL-8, also exported as the K-8 Karakoram, is a tandem 2-seat basic jet trainer developed jointly with Pakistan in the 1980s. Around 350 are in PLAAF service, distributed across flying schools that turn propeller pilots into jet pilots. It is not a glamorous aircraft. Few people talk about it. But without it, none of the rest of this inventory exists. Then comes the machine that actually prepares a pilot for a 4th-generation fighter. The Guizhou JL-9 Mountain Eagle entered service in 2009 and is the primary advanced jet trainer at PLAAF academies. Supersonic, twin-seat, built specifically to simulate the handling characteristics of modern fighters so that students arrive at their first operational aircraft with something more than theory in their heads. The Hongdu L-15 Falcon takes that concept further. It is technically a trainer, but the combat-capable export variant, the L-15B, has been sold to the United Arab Emirates as a light combat aircraft. The PLAAF version first flew in 2006 and entered service around 2016. Supersonic, twin-engine, capable of carrying live weapons. The line between trainer and fighter starts to blur here, and that is entirely deliberate. Finally, there is the JJ-7, the 2-seat supersonic trainer version of the J-7 family. The last one was delivered to the PLAAF in 2017. That same year, the J-20 stealth fighter entered service, an aircraft lineage that traces directly to a Soviet MiG-21 copy was still being handed to Chinese pilots in the same calendar year as China's first operational stealth jet. That overlap, more than any statistic, tells you something about the scale of what was happening. Chapter 2. The Long Shadow of the MiG. Every Air Force carries its history in its oldest machines, and the PLAAF is no exception. The Shenyang J-7 is a Chinese-developed evolution of the Soviet MiG-21, a Mach 2 capable delta-wing fighter that first entered PLAAF service in January 1966 after a 7-year delay caused by the Sino-Soviet split. Moscow had pulled its advisors out in 1960 and taken the blueprints with them. China finished the aircraft anyway. From memory and incomplete documentation, over 2,400 were eventually built. China kept exporting derivatives until 2013, when Bangladesh received the final batch. A handful of upgraded examples remain in second-line and training roles today, still recognizable as the machine they were always trying to copy. The J-8 is different. This one matters more than people realize. China's first completely indigenous jet fighter design, the J-8, was conceived in 1964 as a twin-engine, high-altitude interceptor. Development dragged across the entire Cultural Revolution, a decade in which engineers were persecuted and institutional knowledge was systematically destroyed. It finally flew in July 1969, 5 years late. The J-8-2, which appeared in 1984, moved the air intakes to the sides of the fuselage and freed the nose for a proper fire control radar. For the first time, a Chinese fighter could engage targets beyond visual range. Approximately 70 to 100 remain in active service today, used primarily for training and second-tier interception duties. The Nanchang Q-5 Fantan deserves a moment here, because it represents something important. It is a ground attack derivative of the J-6, which was itself a copy of the Soviet MiG-19. The Q-5 had a redesigned forward fuselage, twin lateral intakes replacing the nose intake of the parent design, and an internal weapons bay. It first flew in June 1965. An estimated 118 are still flying, making it one of the longest-lived combat aircraft in any major air force in the world. It was the PLAAF's primary strike platform for 2 full decades of Cold War tension, and it is still here. From the J-7 to the J-8-2, the runway continues. The Xi'an JH-7 Flying Leopard closed the gap between legacy attack aircraft and genuine precision strike. This is a twin-engine supersonic fighter-bomber, and what makes it remarkable is the engine inside it. British Rolls-Royce Spey turbofans, acquired through commercial channels in the early 1970s, years before any formal opening of Western-Chinese relations. China studied those engines for 2 decades. The JH-7 itself was tortured in development, stretching across nearly 20 years. The advanced JH-7A variant did not reach operational units until the early 2000s. When it did, it was the first Chinese aircraft designed from the outset for the strike role, not adapted to it. It could carry anti-ship missiles. It could deliver precision-guided munitions. Nothing in the Chinese inventory before it could do both. Chapter 3. The Flanker and What It Unlocked. The Soviet Union collapsed in 1991. China moved within a year. In 1992, the PLAAF signed a contract for 24 Sukhoi Su-27 SK Flanker B aircraft, $1 billion. It was the most significant single acquisition in the Air Force's history. The first time China had purchased a genuine fourth-generation air superiority fighter capable of matching Western designs on roughly equal terms. Twin Saturn AL-31F turbofans, a maximum speed of Mach 2.35, a combat radius exceeding 1,500 kilometers, the N1 radar capable of tracking multiple targets simultaneously. Against the J-7S and J-8S that still filled the PLAAF's hangars, the Su-27 was not an upgrade. It was a different category of machine entirely. A license production agreement followed in 1996. Shenyang would build 200 copies, designated J-11, using Russian-supplied components and Russian engines. China completed 105 of them faithfully to the licensed design, then stopped. The remaining airframes were built with domestic components. Moscow protested. Beijing proceeded. The J-11B, which entered service around 2006, replaced the Russian engine with the Chinese WS-10 turbofan and the Russian avionics with Chinese systems. Reverse engineering at industrial scale, exactly the playbook the Soviets had written in the 1940s when they copied the American B-29. Between 2000 and 2004, China acquired 76 Su-30 MKK and 24 Su-30 Mk2 aircraft. Twin-seat strike variants with a genuine multi-role capability the original Su-27 had never been designed for. The Su-30 MKK became the PLAAF's long-range precision strike platform for the first decade of the 21st century. The aircraft that could actually threaten surface targets at range, with guided weapons. China's final Russian purchase came in 2015, 24 Su-35S aircraft, fully delivered by 2019. The stated motivation, at least partly, was the Saturn AL-41F1S engine with its three-dimensional thrust vectoring nozzle. China wanted to study that technology for its own next-generation power plant programs. As of 2025, the PLAAF and Chinese Naval Aviation operate approximately 319 flanker family aircraft across all variants, more than any country outside Russia. Born from the Su-27 family but built for the sea, the Shenyang J-15 Flying Shark is China's carrier-based fighter, derived from the Su-33 Flanker D and developed specifically for planned carrier operations. It entered service in 2013, making China one of the very few nations to operate a fixed-wing carrier aviation program. The J-15 is the heaviest carrier-borne fighter currently in operational service anywhere in the world, heavier than the Fa-18 Super Hornet, and that has created persistent engineering challenges. An improved variant, the J-15T, entered active service in October 2024, counterpart-capable, meaning it launches from an electromagnetic catapult rather than a ski jump ramp, and equipped with fifth-generation avionics. The J-15T is designed specifically for the Type 003 carrier Fujian, which uses an electromagnetic launch system comparable to the American Gerald R. Ford class. The J-11B gave engineers something else to work with. From its twin-seat derivative, the J-11BS, came the machine that now forms the offensive backbone of the entire PLAAF. The Shenyang J-16 entered service in 2015. A true multi-role platform, air superiority, precision strike, anti-ship, all from the same airframe. By 2025, approximately 450 J-16S are in service, the fastest production ramp of any Chinese fighter in history. The J-16D is a separate conversation. It first flew in December 2015 and is a dedicated electronic warfare variant that replaced the air-to-air missiles with jamming pods and anti-radiation weapons. China's first purpose-built airborne electronic attack platform, the equivalent of the American EA-18G Growler. In 2022, a J-16D intercepted an Australian P-8 maritime patrol aircraft over international waters and released a bundle of chaff that was ingested by the P-8's engines. A demonstration of exactly what this aircraft was built to do. Chapter 4. What China built for itself. The Chengdu J-10 program was launched in February 1984. The requirement was straightforward in concept and nearly impossible in execution. China needed a fourth-generation multi-role fighter it had designed and built entirely on its own. Development took 14 years. American spy satellites first photographed prototypes at the Chengdu facility in 1994. The Chinese government said nothing. The first successful test flight did not occur until 1998, and it required a Russian-supplied Saturn AL-31FN engine because China still could not produce a competitive domestic turbofan. The J-10 entered service in 2004. China officially acknowledged its existence in 2007. The J-10C, the current production variant, carries an AESA radar, the Chinese WS-10B engine, and the PL-15 Beyond Visual Range missile. As of 2025, all J-10 variants combined number approximately 550 aircraft in service. In 2025, a J-10C was publicly credited with achieving an aerial kill against an enemy Rafale using a PL-15, the first ever claimed combat kill by a Chinese-designed fighter in history. Whether or not the full details are confirmed, the missile and the aircraft are now a matter of operational record. 650 fighters of three types, all domestic, all built since 2004. Now to the bombers. China's entire strategic bombing fleet consists of one airframe family, the Xian H-6. Based on the Soviet Tupolev Tu-16 Badger of the 1950s, a design that was already old when China first built it under license and has somehow never left, what China has done to that airframe, however, is the story. The H-6K, operational since approximately 2009, features more efficient turbofan engines, a range exceeding 6,000 kilometers, and 6 external hardpoints for long-range cruise missiles, such as the CJ-10A land attack variant or the CJ-20 anti-ship cruise missile with a range exceeding 1,500 kilometers. The H-6N goes further. It adds an in-flight refueling probe and an enlarged internal weapons bay capable of carrying an air-launched ballistic missile, the CHA-SX-13, that gives it a potential nuclear delivery role. As of 2025, approximately 209 H-6 aircraft remain active across all variants. A 50-year-old airframe carrying missiles that did not exist 5 years ago. Chapter 5: The Eyes and the Reach. A modern Air Force is not just its fighters and bombers, it is the network behind them. And the PLAAF has spent the last 2 decades building that network from scratch. Start with transport. The Xian Y-20, known informally as the Chubby Girl, is China's first indigenous heavy strategic airlifter. It can carry up to 66 tons, and as of early 2024, more than 51 Y-20A models were confirmed in service. That number has continued to grow. The YY-20A, also designated the Y-20U, is the tanker variant. It features underwing hose and drogue refueling pods and an internal fuel capacity exceeding 90 tons. Its first flight was in January 2023, and at least 17 are in service as of early 2025. Replacing the 3 Russian-supplied Ilyushin Il-78M tankers that had served as China's only strategic refueling capability. The Il-76MD, a Soviet-era heavy transport acquired in the early 1990s, continues to serve alongside the Y-20, used extensively for airborne operations with the 15th Airborne Corps. Below those heavy airlifters, the Shaanxi Y-8 and its modern successor, the Y-9, form the connective tissue of the Special Mission Fleet. These 4-engine turboprop workhorses have spawned an extraordinary number of variants. The Y-8G is a dedicated electronic warfare and jamming platform, with 17 known examples in service. The Y-9JB is a signals intelligence aircraft that has been confirmed in operation since 2022, regularly observed conducting electronic reconnaissance around Japan. There are psychological operations variants, maritime patrol variants, and calibration variants. The Y-8 and Y-9 are not glamorous. They are the most useful aircraft the PLAAF operates. Then there is the KJ-2000, China's first large rotodome AEW&C aircraft, based on the Il-76 airframe. 4 were converted from transport duties and entered service in 2004, giving the PLAAF its first true airborne command and control capability. The smaller, turboprop-powered KJ-200 followed, providing a more deployable AEW option for regional operations. The KJ-500 is the current standard. Built by Shaanxi Aircraft Corporation on the Y-9 airframe, it is China's third-generation AEW&C aircraft, developed in the late 2000s to address growing demands for detection capability, identification, and rapid response. A special variant, the KJ-500A, adds an aerial refueling probe for extended endurance over open water. Approximately 150 special mission aircraft of all types are in service, including KJ-500 platforms. Pakistan announced plans to acquire the KJ-500 inches June 2025, the first confirmed export of China's most capable AEW platform. Alongside those comes the KQ-200. This is the machine most people have never heard of. China's dedicated anti-submarine warfare and maritime patrol aircraft built on the same Y-8 and Y-9 airframe family, but equipped with a chin-mounted surface search radar, a magnetic anomaly detector in a tail boom, an electro-optical belly turret, and internal bays for lightweight torpedoes and sonobuoys deployed from 4 rotary cabinets. The PLAAF received its first KQ 200 inches 2015. By 2023, it was deployed across all 3 naval theater commands. This is the aircraft designed specifically to find submarines. Before it existed, China had no purpose-built platform for that role. For maritime patrol and electronic surveillance, the PLAAF also operates a small number of Boeing 737 airliners, modified with specialized sensors for overwater reconnaissance, detecting aircraft, submarines, and surface vessels. A commercial Western airframe in a military intelligence role. An anomaly in an inventory that has otherwise moved comprehensively toward indigenous production. The Tupolev Tu-154M completes the electronic picture. The Soviet-era trijet airliner, acquired during the Soviet era and converted for the electronic warfare role, serves in approximately 7 airframes configured for active jamming. It works alongside the Y-8G and Y-9JB fleet to give the PLAAF a layered, multi-platform signals capability. For rotary wing ISR and shipboard ASW duties, the PLAAF operates the Kamov Ka-28 Helix, a Russian-supplied helicopter acquired alongside Sovremeny-class destroyers in the late 1990s and early 2000s. Its distinctive coaxial rotor design eliminates the tail rotor, reducing the shipboard footprint on destroyer decks. The Ka-28 remains the primary shipborne ASW helicopter until the domestic Z-20 family completes its replacement. Speaking of helicopters, the PLAAF and PLNAF operate 3 main domestic rotary wing families. The Changhe Z-8 and its successor, the Z-18, are medium-lift platforms derived from the French SA-321 Super Freelon, with the Z-18 entering service in 2018. The Harbin Z-9, a licensed copy of the French Eurocopter AS-365 Dauphin, first flew in 1981 and entered service in 1994, with over 200 airframes completed. Its derivative, the Z-19, is a dedicated 2-seat reconnaissance and attack helicopter. Then there is the Z-20, China's indigenous medium utility helicopter that mirrors the configuration of the American UH-60 Black Hawk. The Z-20 entered service around 2019. The Z-20K is a naval carrier-based variant. The Z-20KA is a special operations version confirmed with the PLA Airborne Corps by 2022. The Mi-17, acquired from Russia and still in service in transport and logistics roles, bridges the gap until indigenous production fully takes over. Completing the reconnaissance picture from altitude is the WZ-7 Soaring Dragon, a jet-powered, high-altitude, long-endurance, unmanned aircraft with a distinctive joined wing configuration and a service ceiling estimated above 18,000 meters. It carries electro-optical and infrared sensors alongside a synthetic aperture radar, and it operates well above the reach of most air defense systems, China's equivalent of the American RQ-4 Global Hawk. It fills the strategic reconnaissance role that no manned aircraft in the inventory can cover. Chapter 6. The Drone Fleet. China entered the armed drone business with the Wing-Lung-1, the GJ-1, a medium-altitude, long-endurance platform developed by Chengdu Aircraft Industry Group, first flight in 2007, entering PLAAF service around 2011. Maximum speed of 280 km per hour, operational range of 4,000 km, endurance of more than 20 hours. 2 underwing hardpoints for missiles, bombs, and guided rockets. It has been exported to the UAE, Saudi Arabia, Kazakhstan, Egypt, and Serbia. It established the template. The Wing-Lung 2, designated GJ 2 inches Chinese military service, expanded on that template in every dimension. Unveiled in 2015, officially entering PLAAF service in November 2018. 6 underwing hardpoints instead of 2. A satellite communications link enabling operations beyond 1,000 kilometers from the ground control station. It carries laser-guided bombs, air-to-surface anti-tank missiles, and precision-guided munitions. Aerodynamically, it features a distinctive V-tail and retractable landing gear, and it competes directly in the export market with the American MQ-9 Reaper. Bangladesh ordered 4 in 2025. Then there is the BZK-005 Giant Eagle, a different class of machine, less about striking and more about watching. The BZK-005 is a high-altitude ISR platform developed by Beijing University of Aeronautics and Astronautics, capable of sustained missions at altitudes above 8,000 meters, and equipped with satellite communications for beyond line-of-sight operations. It has been observed over international waters, conducting extended surveillance and electronic reconnaissance missions, endurance exceeding 40 hours. The TB001 twin-tailed Scorpion, developed by Tengdan Technology and entering PLAAF evaluation around 2021, is a twin-boom armed UCAV with 12 hardpoints and an endurance estimated at over 35 hours. China is producing armed drones faster than most countries are counting them. And then there is the WZ-8. This one is in a category of its own. A rocket-powered supersonic reconnaissance UAV, air-launched from modified H-6 bombers, and capable of speeds exceeding Mach 3. It was introduced publicly in 2021 and entered confirmed service by 2023, designed to penetrate defended airspace at hypersonic speed and conduct high-resolution imaging and electronic reconnaissance. There is no Western equivalent currently in operational service. Chapter 7. The Fifth Generation and What Follows. On the 11th of January 2011, a prototype aircraft numbered 2001 lifted off from Chengdu and flew for approximately 15 minutes. Western intelligence analysts had not expected China to fly a fifth-generation prototype for several more years. The J-20 Mighty Dragon had arrived ahead of schedule, and the assumptions that had governed Western assessments of Chinese aviation capability were revised the same afternoon. The J-20 is a twin-engine, Delta Canard stealth fighter with internal weapons bays, an AESA radar, and a low observable configuration optimized for penetrating contested airspace. It entered PLAAF service in March 2017. The first combat unit was formed in February 2018, making China the second country in the world, and the first in Asia, to field an operational stealth fighter. From 50 airframes in 2020, the J-20 fleet reached 300 by mid-2025, a five-fold increase in 5 years. In March 2022, a U.S. Air Force airborne early warning aircraft failed to detect an approaching J-20 until it was very close, a fact publicly confirmed by the Pacific Air Force commander. In March 2023, Chinese state media confirmed that J-20s were being used to simulate F-35s in opposing force training scenarios. The J-20s, the twin-seat variant, began appearing in 2021. It is widely assessed to be configured for controlling autonomous wingman drones, placing it at the leading edge of manned-unmanned teaming doctrine that no Air Force has yet fielded at operational scale. That brings us to the J-35A, China's second fifth-generation fighter, officially unveiled in late 2024 and now in serial production. A lighter complement to the J-20, designed to operate alongside it in the Air Force role and to serve in a naval variant on Chinese aircraft carriers, eventually replacing the J-15 family. A single country simultaneously running 2 fifth-generation production lines, 1 heavy air superiority fighter, and 1 lighter multi-role platform, is something that has not happened outside the United States. In 2024 and 2025, multiple examples of 2 different tailless flying wing prototypes were observed at Chinese test facilities, designs that analysts have labeled 6th generation. The specific capabilities of these aircraft are not publicly known. What is publicly known is that they are flying. China is the only country besides the United States with confirmed next-generation manned fighter prototypes actively conducting test flights. The H-20 stealth bomber, developed by Xi'an Aircraft Corporation, represents the final gap in the current inventory. A purpose-built, low-observable strategic bomber designed to replace the H-6 family with a platform that does not trace its ancestry to a 1950s Soviet airliner. Development has been confirmed for over a decade. Initial operational capability could arrive within the next several years, and a separate production capability because aircraft need to get to their targets. By 2027, AVIC manufacturing facilities are assessed to be capable of delivering at least 250 aircraft per year to the PLAAF, with total production capacity across the corporation reaching 300 to 400 fourth and fifth generation fighters annually. In 1950, fewer than 100 aircraft. In 2025, over 1,500 frontline combat aircraft, 300 J-20s, 450 J-16s, 550 J-10s, 200 bombers, over 50 heavy transports, 17 dedicated tankers, a full-spectrum special mission fleet, the most capable carrier fighter in Asia, and at least 2 prototypes of the generation after that. The Air Force that went to Korea with borrowed Soviet jets and pilots trained in months built all of this through licensed copies, reverse engineering, technology acquisition, foreign purchase, and finally, genuine domestic innovation at industrial scale. It did not happen gradually. It was forced into existence by embargoes, broken agreements, and the slow accumulation of everything it was never supposed to have. It is not finished.